So normal form. So there are actually two different kinds of normal forms. So normal forms actually let me explain this and then actually we can proceed to the next one. So a normal form is expressing the Boolean expression, that is which is the output required in two different forms. One is DNF format. DNF means disjunctive normal form. And the second one is CNF, conjunctive normal form. Now, disjunctive normal form is nothing but expressing the function as the sum of products of all the inputs as an expression. Is called DNF, disjunctive normal form. So you are expressing the output as the sum of products of all the inputs. Now there actually how we are going to proceed, that one is, suppose I have A, B, C, these are the inputs. Now for this actually I want a function, I wanted to design a system where for the inputs of, and this is the output I need for 0, 0, 0, let us say I need 1, and then 0, 0, 1, let us say I need 0, and 0, 1, 0, I need 1, 0, 1, 1, I need 1, and 1, 0, 0, I need 0, and 1, 0, 1, I need 1, and then 1, 1, 0, I need 1, and 1, 1, 1, I need 1. So let us say this is the required output I need for this kind of input. Now for this actually, for DNF, disjunctive normal form, what we need to do is we have to select the cases where the output should be 1. So this is the method of selecting for DNF. Now here actually this is 1, and this is 1, and this is 1, and this is 1, and this is 1, this is 1. Now if you notice, this is the required output for which I wanted to design for these inputs. So it's not a truth table at all. So this is the required one, and this is the available inputs. For this input it should be 1, for this input it should be 1. Like this actually, these are the requirements I have given for the designer. So the designer has to design a circuit which will satisfy this. Now for this actually there are two different methodologies we are going to adapt it here. So that is either DNF or actually CNF format we need to express first. So that expression is here, if this has to be 1 for these inputs, I have to have A bar, B bar, C bar, so that the product of all these things together will give 1 if I multiply A bar, B bar and C bar. Similarly, here I need to multiply A bar, B, C bar. Similarly, for this one, A bar, B, C. And for this one, A, B bar, C. And for this one, A, B, C bar. And for this one, A, B, C. Now, for these inputs actually, if you notice, if I give an AND gate like this, A bar, B bar, C, I am going to get an output of 1. Now if I add all these things together, I call this function as the DNF. So that is f of A comma B comma C, which is the DNF, disjunctive normal form. So this is y equal to the sum of all these things, that is A bar, B bar, C bar plus A bar, B, C bar plus A bar, B, C plus A, B bar, C plus ABC bar plus ABC. So this is the DNF. Got it? Understood? Now actually if I apply y bar on it, so this is going to be, suppose if I apply y bar, then A bar, B bar, C bar, whole bar dot A bar, B, C bar, whole bar dot A bar, B, C, whole bar dot A, B bar, C, whole bar dot A, B, C bar, whole bar plus dot A, B, C, whole bar. So if you apply y bar on it, so you are going to realize this one. Now here, if you notice, this is A bar, B bar, C value is anyway, we know that it is going to be 0. And the inverse of that is going to be 1. Right? So here, this one, with the help of De Morgan's principle, what you can do is, this can be written as, so A bar whole bar plus B bar whole bar plus C bar whole bar, so which is nothing but, so this is A plus B plus C getting multiplied by the next one, A plus B bar plus C. So maybe actually you can note down this. I am going to explain clearly the CNF and the way actually how we can bring from DNF, how we can bring CNF. First you note down this. Then so this is the DNF, and this one actually if you write it, then this is going to be CNF. Okay, so let me expand this one. So a CNF is nothing but expressing the function as the product of the sum. So the product of the sum of all the inputs. So this is called the CNF. Now here from DNF we can bring the CNF by expressing y bar. So y bar is going to be, so this one if you write it here, so y bar is equal to A plus B plus C with the help of De Morgan's principle. So with the help of De Morgan's principle, so we can write this is A plus B plus C dot A plus B bar plus C dot A plus B bar plus C bar dot A bar plus B plus C bar dot A bar plus B bar plus C dot A bar plus B bar plus C bar. So this is the CNF. Got it? Now from the diagram, if you want to bring the CNF, then actually what you need to do is you have to call for y bar. So if I put y bar here, and then this y bar, it becomes 0 here, this is 1 here, this is 0, and this is 0, this is 1, this is 0, this is 0, and this is 0. Now for this actually the ones, right? So if you want to get 1 here, then A bar plus B bar plus C. So this one, so you are going to get Y bar as A plus B plus C, and here A plus B bar plus C, and here A bar plus A plus B bar plus C bar, and here A bar plus C, B plus C bar, and this one A bar plus B bar plus C, and this is A bar plus B bar plus C bar. Got it? Now actually this is how actually you have to express it, where you are going to get the value of Y bar. Now this Y bar value, wherever you are getting 0 for Y bar, for that actually you can write, or you can assure that this entire thing should become 0. So for all the inputs where it is 0, the output has to be A plus B plus C, so that it is going to be 0. And here this is A plus B bar plus C. Why? Because A actually already 0, and B actually you can make as 0 by taking bar of it, and C is anyway 0. The sum of all these three things, A plus B bar plus C, is going to be 0. Now like this actually, wherever 0 is there, you have to identify those zeros. In case of sum of products, actually you are identifying ones as the required values. In case of product of sums, actually you need to identify zeros, and then you have to identify the zero sums. So this is a zero sum, and this is a zero sum, this is a zero sum. Like this actually you have to identify all the zeros and then multiply together so that you are going to get Y bar value. Now if you want to get the Y value, then actually you can take the inverse of it, which is that again you can apply De Morgan's principle to get DNF format. So these are interchangeable. Got it? Understood? Vishal. So see this, last row is 1, 1, 1. Now for this the bar is 0. That means you can add A bar plus B bar plus C bar. That's all. So A bar plus C bar plus B bar. So this is the normal forms. So I have covered all the aspects of these things. So memory is just an understanding. So there is nothing to explain there. So let me give you a brief introduction about memory, or actually before that we'll discuss what are the different parts of a computer. So you don't need to worry about all the parts, because actually you are anyway aware of all the parts of the computer, but we'll just touch the hardcore parts. So that is then actually most importantly memory. Here in a computer, if you notice the inside one, so this is called CPU. So this is the central processing unit, and then there is an input device and there will be the output devices, and within this actually there is a CPU, and along with that there is memory. So this CPU is the central processing unit. Here the way computer operates, here it will take input from the user. So this input has to be given by either maybe a user or it may be another system. So you will get an input from here, like in the form of a keyboard key pressed, or actually a mouse got clicked, or a printer command was received. So all those things are the inputs from the different device or from a human, and those inputs are getting captured here by the computer, and then there actually this central processing unit is nothing but the brain of the computer. And then this brain actually will decide what or how to respond for the input, and the response will be given in the form of the output devices. So this output device may be a screen or a printer or actually anything that can be showed from the computer. So this is for the visual purpose. So this is to interact with the computer. So this is to interact with the computer. In the central processing unit, so this is actually, it needs certain memory to store the values. So if you give some command, so first of all actually it needs to understand and it needs to respond as per the requirement. So for that actually the responses and the requirements, everything getting stored in the form of the memory. So in the memory, all the values or the commands or anything that needs to be stored or anything that needs to be remembered by the computer has to be stored in this memory. And then this memory actually, as and when the CPU so ask for the values or the commands, so it will take input from here and then actually try to process. So this is just a brain. So this brain will process and then it will respond for the output. And in this processor, so there are actually different units, that is ALU, which essentially means that a CPU will have arithmetic and logic unit. So this is the main core of it, arithmetic and logic unit. So this is also called as the processor. So this is the processor. So when you buy any computer, right, or any laptop, we will look for the processor. So whether it is i4, i5 or the i7 processor or P4 or what kind of processor it may be. So you will check for the processor because this is the brain. How fast this processor will respond, or actually how fast this processor can process any particular information. So that depends on the capacity of this processor. So more the version, or actually very latest version will have the faster response. So that response actually it is going to get because of multiple reasons. One is how many transistors that are there inside and the speed of each transistor and how fast it can access the memory. All those factors actually will be deciding the speed of this processor. And this processor indirectly is our CPU. And there is an external memory also. So this memory actually, usually there are two different kinds of memories actually we talk about. So one is the ROM and read-only memory. And the next one is the RAM. RAM is the random access memory. Random access memory. Now actually when we want to process any particular information, let us say take the simple example of this one. So when we are reading in a library by sitting on the table, so now actually you wanted to learn something. For that actually you need certain books. In a library there may be thousands of or the lakhs of books that are available. But actually out of that, so in each and every book there one or the other information is going to be there. But actually you need very specific information which is available in 2-3 books. Now what you are going to do, you go to the rack and then actually you will bring those 2 books and then bring onto the table and then you will try to study those 2 books. But actually in your library there are infinite number of books that are available. Now here actually this RAM is nothing but, this RAM actually the books that you placed on the table. That is where you can immediately access and look at the pages. But actually there are many other books that are available on the racks. So those are actually a little far from you. Now when you wanted to access there, you have to go there and bring one more book. So this RAM is the capacity, how many books you can put it on the table. So that is the capacity of the table indirectly. But the external memory is nothing but the entire capacity of the library where it can hold hundreds or thousands of books. So that is the main difference between a RAM and a external hard disk. But this ROM is a different concept. This is read-only memory. So this read-only memory is nothing but when we design a processor, we need certain basic functionalities. Or actually we need to write certain programs so that actually you can build operating systems on top of it. So when we talk about any particular software, right, so there are different levels of software, and then actually this is the CPU where it can understand only the binary digits. Why? Because as I explained earlier, so a binary digit actually will have only two different states. So when you put a switch there, a switch can be on state or an off state. So on state can be treated as one way and off state can be treated as an opposite way. So this is the basic understanding of any binary system. So those are the only two states that you will make use even to design a fastest system, or actually whatever may be the kind of computer system you wanted to design, you are making use of only these two states from the fundamental principle of the binary number system, or in general a number system. A number system can have any number of symbols of your own interest, but actually because the machines are allowing only two different states to be followed, so you can make use of binary number system for designing any kind of machine from the information of representing any information only with two digits, two states. So this is a single statement actually that will be useful for all the computers, starting from the lowest system to the supercomputer. This is the only principle used to design any particular processor or a system. So here actually whatever may be the information you want to store, or whatever may be the information you wanted to interpret, first you have to put it in a form where the machine can understand, but the machine can understand only two states. Now those two states are the on state and the off state. So wherever one is there, you might interpret that as one, you might interpret that as an on state. Wherever 0 is there, you might interpret that as an off state. So 0 and 1 are interpreted by the computer based on the programmer. So that programmer actually he will decide how to interpret the statement, or how to interpret the word, or how to store the word. So there actually, let us say if you wanted to represent a letter A, then actually you might assign a code for this particular A letter, maybe 1101. So this might be 1101 is a letter A which has to be interpreted by the computer. Suppose wherever this 1101 comes, immediately computer thinks that this is a letter A, not 1101 as a binary number. Got it? So this is letter A. Now actually if you want to represent simple 1, you might interpret this as 001. This is the code given for 1, where if you get 0001, then actually you might interpret that as 1. So this interpretation has to be done by this CPU. So this is the hardware programming we call. So writing the program in this particular format is called as the hardware programming. So hardware programming is very, very complex level of programming. Why? Because this complex level of programming, why we are calling that as, so you have to understand the way computer understands any information. Then only you will be able to code the binary systems. So especially 8086 processor coding, or actually whatever may be the processor it is there, if you try to code that microprocessor coding, it will be simple commands like move, copy, like that. Actually there are very basic level of commands will be there. Those basic level of commands are built on top of the hardware programming. So hardware programming is the basic level where the programmer has to interpret everything as in terms of 0 and 1. But whatever the programming languages we use, maybe C or C++ or Java or Python or whatever it may be, all those languages are the very, very high level languages. Why we call it very, very high level languages is, the low level language actually you need lot of intelligence to understand for the low level language, because every brain, so brain has to be think in the form exactly as a computer. Then only actually the way machine thinks, right? If you think in that manner, then only you will be able to code it. Then on top of this hardware programming, one layer will be the processor programming, where you get accessibility for very few commands like move, copy, overload, so interrupt, such kind of processor level of accessibility will be there. So somebody actually, if anybody actually studies EEE or ECE or computer science, so you might be understanding that So there is some processor coding or processor programming will be there. So that is actually microcontrollers programming also will be done with the help of the processor coding, not the hardware level of coding. The hardware level of coding will be done when the processor designed itself, that is in the machine itself actually it is going to be done. So that is the permanent. So that permanent memory, if at all you wanted to store, so that has to be used with the help of this read-only memory. So read-only memory is you will be able to read it, but actually you will not be able to write anything on top of it. So you are reading. These are the basic commands as I explained, right? So the hardware programming, whatever we do, so there actually we will be writing whatever the information needed by the computer. You are not going to erase there, or you are not going to edit anything there. So that is where actually this ROM comes into picture. Now, once the processor programming is done, on top of that actually this processor programming, you will be building a little bit of high-level programming languages like C compilers, or the C++ compiler, or Fortran compiler. So all these are actually the compilers which were built based on this processor programming. So there actually you are going to get the high-level language. Now on top of this high-level language, you might get actually one more high-level language that is very, very high level of languages like Python, where it is almost like writing English. So you will be able to easily understand the programming. So that is as if like you are coding in English. So you just write the English statements. It will be interpreted by one layer, that is, let us say C compiler, and below that there is a processor level of coding which will understand only the C compiler, and from the processor it will try to pass the information to the hardware programming where it understands only the machine level of language, either zeros or ones. So this is the order of priority. Now these languages actually are the programming languages. You are making use of these languages to build the applications. Now operating system is one kind of application where it was built on the processor. So this operating system you will be looking at as if like it is the Windows or Linux or whatever it may be. So these are the kind of operating systems daily life actually you will notice. These operating systems are actually, it will give you a better or an easy interface for the user to interact with the computer. So that interaction actually you can easily do on top of this operating system, because that is the most convenient way which was designed. Otherwise actually you will not be able to interact with the computers. So those people actually who are working on microcomputers or microcontrollers, they have to be very much familiar with the hardware programming and this machine level of programming or the low level language programming. They have to be aware of it, because there actually you will not get interface like operating systems there. So you have to directly interact with the processor. Like actually, suppose if you take a printer, so a printer has to be interact with the computer. Now that interaction, the printer has to understand what this information is passed. So there the programming actually, so the printer processor, whatever it is there, so there actually the memory is not sufficient, or the processor capacity is not sufficient to understand a high level language. So there the interaction has to be done only with the help of processor programming there. So there actually such kind of operating systems needs to be adopted there. Got it? So this is the basic understanding of the computer, how it is going to be built. Now this concept of memory is, first of all actually we need to understand what is a memory at all. So we are remembering something. So what it means by that? What is a memory by definition? Can somebody give me an idea what is a memory? How can we design a memory? Is a storage location, but actually how to store it? What is the concept behind it? So when we say that there is some memory to certain machine or a person or whatever it may be, where we can store data, but actually what is the concept behind it? How we can store it? In our memory actually, so there is a chemical reaction that is happening where actually we are able to store the information. Bits can be stored. How the bit can be stored? What is the logic behind storing a bit?